Then Dr. Datta sent me the team that's observing today to protect tomorrow. That's the WMO theme he told, and I can talk something about that. So first I scratched my head and I coined this title first. Normally I prepare the talk and then give appropriate title, but this time, because I don't know what I am going to talk or what I can talk, what is appropriate to talk at IITM. So I first coined this talk from data to safety, because as Dr. Surya was telling that I was an observational oceanographer actually. When many people they were shifting to modeling oceanographers, I used to tell that I am the only observational oceanographer now left out in physical oceanography division of NIO. So the data, then we converted that as services in the INCOIS. So that data translated itself to the safety and the protection and providing services at INCOIS. So I thought that this is what I have done. So from data to safety and observing today to protect tomorrow, that is from the WMO theme in the era of climate change. So I made a Khichdi type title. I hope you appreciate that title. And then I started thinking about what I should talk, or how I can prepare this title. So I don't think anyone can go beyond the formation of the earth to start with. So I decided to start from the formation of the earth, which was formed about 4.54 billion years ago from solar nebula. And the so-called life, abiogenesis, or sort of chemical reactions, self-replicating cells started forming about 3.7 to 3.8 billion years ago on the earth. And finally Homo sapiens came in existence over a wide-ranging time period, about 75,000 to 10,000 years ago. So I think by the time the 10,000 years ago, the earth system stabilized and the life started flourishing on this earth system. And agriculture also came around about 10,000 years ago, maybe 8,000 or 9,000. Around 10,000 years ago, the agriculture also came in. And by the time the earth system stabilized and it formed as distinct spheres, the atmosphere formed, what we have today, hydrosphere formed, the oceans, lakes and other waterways, lithosphere formed, and cryosphere formed, Arctic, Antarctic, then our Himalayan glaciers, Alps glaciers, etc., they formed, and the biosphere where the life started thriving. So the earth system maintained a balance between these five spheres and constantly interacted between each of them, like atmosphere and life, or life and oceans and atmosphere, etc. And that maintained a stable system, or what we call the earth system. And the natural variations of the climate system arises from interactive feedback among the earth system. So we had some climate changes on the way after 10,000 years. There was a little ice age, then little ice age, etc. But that stabilized the earth system and the life on the earth. Then people started observing, because the observations started on this natural phenomena, and people started observing the environment changes over the year in different forms. We have a spring and summer, then a monsoon and all these things. And they observed carefully this environment and related that, because as we say that the science is nothing but cause and effect understanding. So they not only observed there are changes, these changes have something to do with the cosmic order what is going on, and they even categorized this in 6 seasons like Vasant, Spring, Grishma, Varsha, Sharad, Hemant and Shishir, and related that with the seasons are forming when the sun is at a particular position of the constellations. For example, the Vasant or the spring season forms when the sun is in Meena and Mesha Rashi or constellations. Like that they could make it understand that this is how the seasons are changing and this is how the cyclic change of our life is going on. And not only that, they could even observe that what changes are going on in our body when due to these seasons. So that so you can just think about, it's not only the seasons, the meteorological effects on the health and the human life cycle itself was done. So I was actually talking to a friend of mine who is a doctor. He was telling me about, there was a study which he conducted, but various reasons it is not yet published, for example. See, in India we all talk about what we need is super specialities. Super specialities for each of our organs and super specialities for each of the diseases. That is what everybody wants and everybody promotes that. But this survey actually it says that, and that survey was mainly to find out what kind of doctors we had to produce in the country, what kind of doctors we need and how many we need for that purpose. But shockingly, it was understood that what we need is the doctors who can treat the upper respiratory diseases. And most of the population, 75% of the population, sometime or other is suffering because of the upper respiratory problems. But we don't have doctors to treat that, but we have specialists for unknown diseases and unknown specialities. So these are issues which has to be formed from the, because the corporates will lose the sheen if they say that what we need is simple MBBS doctors to treat this sarvajanic problem. So that information has to be suppressed, and we have to promote this more speciality, more specialization, etc., etc. So what I mean is this all comes through the observation, and observations are the basis of each of these conclusions. So if you look at the reference to rain and weather predictions, they are found in several ancient texts, like in Rig Veda itself there are mentions about predicting or the oncoming of the rains. Srimad Bhagavat, Parashara Samhita, Varaha Mihira, Brihat Samhita, Panini's Ashtadhyayi, and Meghamala in 800 AD. So several ancient texts have the mention about the prediction of weather, and also describing the weather, how the patterns are changing and how those changes are happening. And they evolved through the observations and passed down through generations. That's how the ancient knowledge was passed down. And it took the form of Panchang. We all know that what is the Panchang. There is a booklet which is printed every year, providing the astronomical data in that. And Panchang includes astronomical data, planetary positions, and astrological predictions even included. Even today also, if you go to the villages, they will not go by IMD's predictions. Of course, IMD predictions are valid. I am not questioning IMD predictions, but they will look for that day when that star comes in the sky to do the seeding or harvesting or for other agricultural activities. This is the truth even today, because they feel that with this information they will be able to, in fact, I could not get that paper in the short time. I remember that Professor Sulochana Gadgil had published a study along with someone else by comparing how these agricultural activities based on these panchangs, how they work and what kind of benefits they are providing. So even today also the panchang is used to determine the timing of agricultural activities, planning festivals and daily life in rural India. In 1854 November, there was a storm which destroyed us during the Crimean War. You know, Crimea is attached, earlier it was with Ukraine, now Russia has taken over that a few years ago, that peninsula. So that there was a war at that time where the Western forces and Ottoman Empire was fighting with the Russian Tsars. I think Charles Nicholas II or Nicholas III was the Russian Tsar at that time. So in that war, they got destroyed several of British and French vessels which were anchored in the Black Sea. But as the storm passed over the Paris observatory, from that pressure drop, the director of that observatory, he calculated and he realized that there was enough time actually to give warning. If it was observed properly, the warning could have been given to the French and British vessels and they could have been saved. But they didn't have that means at that time to observe in Crimea, which is far east, and come up with those kind of observations. And so they lost several of their ships. And realizing that, because they realized that now we not only need the meteorological data at that location, we also need elsewhere. So that realization has come, and in 1873, the first International Meteorological Congress met in Vienna to establish International Meteorological Organization, or IMO. That was established as a non-governmental organization that was responsible for international cooperation in meteorology from its creation until the end of Second World War. Later, it was realized that there should be a more formal arrangement, and according formal arrangement and global cooperation on weather, climate and water data, promoting standardized observations, etc., etc. And accordingly, the WMO, or Meteorological World Meteorological Organization, was established on 23rd March 1950 as a specialized UN agency with 193 member states and territories as members, and it was headquartered in Geneva. All of us knows about that. And the main objectives of WMO was to act as the UN authoritative voice on the state of atmosphere, oceans and climate, and providing critical information for disaster risk reduction and environmental protection, to manage the global basic observing network and promote free open data exchange to improve forecasting, especially in developing countries via systematic observations financing facility, to operate the World Weather Watch and contribute significantly to climate change research. And by the time the scientists or the people started realizing the importance of observations, as Michael Faraday says, I was never able to make a fact my own without seeing it. And the descriptions of the best works altogether failed to convey to my mind such knowledge of things as to allow myself to form judgment upon them. It was so with new things. So he realized the importance of observations. And Henry Stommel, one of the most famous eminent oceanographer, he says that the data gathered from the ocean is the very blood of our science. Similarly, the others like Walter Monk and Matthew Murray, who is considered as the father of oceanography, who prepared the atlases based on the ship logs of historical ship logs, and Mark Abbott, who emphasized that he was the president of Ocean Society, that the era of big data is transformative, with data being crucial for ocean-going instruments and observation. So it is established that better observations lead to better predictions. Predictions help protect lives and livelihoods. So accordingly, the WMO, after its formation, it established a network of weather stations all over the globe. They came up, and radio Sunday observation stations also all over the globe came up. And today about 9,000 stations are transmitting data over GTS for the purpose of weather prediction centers. Maybe IITM also may be receiving, at least I know that NCMR WF is receiving this GTS data, and they capture that data and assimilate in the models and provide that data to IMD as well to run their forecasting models. So the data is being used in various forms, various models, and for various purposes. So in India also we have a very good network now of surface observations, upper air observations, Doppler weather stations, rainfall stations, plus many other stations. So we have organized that under 18 meteorological centers, and under the 36 subdivisions for weather prediction purposes. There are 6 regional centers. They are the major hubs located in New Delhi, Calcutta, Mumbai, Nagpur, Guwahati, and Chennai. And there are 18 meteorological centers and 36 divisions. And they manage the network of observations. This slide I got from Dr. D.S. Pai, which says that there are 48 Doppler weather radars, then 56 radio Sunday stations all over India, and about 1200 AWS, and nearly 1400 automatic rain gauge stations, plus there are several other radiation, sky radiometer, etc., at the different locations. So we have a formidable observing system in India as well. One thing we have to notice is that, see, for example, in 1999, we had the super cyclone which hit Odisha coast, and that had a central pressure drop of 968 millibar, but caused a death of more than 10,000 people, because we could not give a proper warning or timely warning so that the people could be moved away from the coastal areas. But you compare that with the super cyclone Phylline in 2013 in Odisha, again in Odisha itself, which had a pressure drop of 940 millibar. So this was much more stronger than to 1999 super cyclone. But the death reports are hardly 6 people, that too because of electrocution or some other secondary effects. Otherwise, we could save each and every life from the Odisha coast. So I think we have made over a period of 20 years or 22 years, we have made tremendous progress only because we have more observations and more science and more facilities and more people working in those lines, so that we could save the lives. Similarly, on the ocean side also, the Intergovernmental Oceanographic Commission, they have coordinated the observations in the oceans. This is a snapshot of observing networks in the world oceans. And even in Indian Ocean also, we have a formidable observing network consists of Argo floats, drifting buoys, what Dr. Surya also was mentioning. Then there are moorings, which are reporting data to the centers, which assimilate that data in that. So with that, we have achieved the targets of early warnings. We can now provide early warnings on tsunamis, storm surges, cyclones, and coastal flooding, as well as providing a service called potential fishing zone advisories, which tells the fishermen which are the areas where they can get a better catch, so that they need not go around and search for fishing ground before casting their nets. And of course, the ocean state forecast, which is equally important for the fishermen as well as for the Navy and other users of maritime environment, like waves, currents, SST, MLD, thermocline depth, etc., etc., and many more other services. So all these things works if the picture in this cartoon and these budgets are okay. So if we know that we get the energy from the sun warms the earth, sunlight comes through the atmosphere and heats the land and oceans, and the budget is given here in the form of a cartoon. And earth tries to cool itself, because earth don't absorb the entire sun's radiation which is coming back. It gives out some of that, and it maintains a balance. But the problem is the greenhouse gases trap some heat, and gases like carbon dioxide act like a thin blanket over the Earth's atmosphere. And more greenhouse gases means thicker the blanket, and more heat stays near the surface and Earth becomes warmer. So that is the problem which we are got in now. And because of that, the global temperature also is steadily increasing and it is going up. Again, the observations came in the help. We never knew earlier that the carbon dioxide is keep on increasing, but Professor Charles David Killing, he started observing carbon dioxide, and there was not much hue and cry at that time. But this professor, he established an observatory in Mauna Loa in Hawaii and kept observing the carbon dioxide concentration in the atmosphere, and that became the most authentic observation to show that how carbon dioxide concentration is keep on increasing in the atmosphere. So in December 2021, it was about 416.71 ppm. By January 24, it became 422.8 ppm, and March 2026, 427.3 ppm. And right now we have about 406 427 ppm of carbon dioxide in the atmosphere, and carbon dioxide equivalent, if we calculate with the other greenhouse gases like methane and other nitrogen and other gases, it comes to 542 ppm. And most important is AGGI, or Annual Greenhouse Gas Index, which says since 1990, because 1990 was taken as the base year, because 1990 was the year of Kyoto Protocol, where every country pledged that now we will cut down our emissions, or we will not emit more than a certain percentage of what we were emitting earlier. And because of that, and that year if we take as 1, so now it is 1.54. That means since 1990, another 54% we have added to the atmosphere. So actually, if you look at this curve, it took 240 years for the AGGI to go from 0 to 1, or up to 1990. Or those people are very inefficient those days, and the very efficient population now took only 34 years it to increase by another 54%. So that is the rate at which we are adding the carbon dioxide into the atmosphere. And the report says that the CO2 increase during 2024 was 27% larger than previous largest recorded annual increase of 2.94 plus or minus 0.07 ppm in 2015. So we are not only adding, we are adding more and more now after year after year. So now after 26 only we will come to know how much carbon dioxide is being intensively added in the Gulf country, in the GCC or the Gulf area. Now what is going on there, because they are not burning the fossil fuel there. So but it will add carbon dioxide. So that's what is going on now. And the temperatures are going up. We are going to crossing 1.5 degree. In fact, we crossed the last year. But if you take the long-term mean, we are yet to cross that 1.5 degree. But soon we are going to cross that 1.5 degree. And if we look at the rate of warming, at the rate at which we are warming, earlier in earlier it was something like 0.2 degrees per decade, and that has now changed to sometime in 1990 it was 0.2 decade, where we pledged to reduce the emissions, and now it is almost coming to the 0.4. So we have doubled the rate of warming also because of the addition of carbon dioxide which is going on into that. Somebody has looked at, maybe our IITM CCR also must have looked at this, which says that the monsoon rainfall will increase at different scenarios, and they have given the confidence limit, so I have no reasons not to believe that. So it looks like the monsoonal rainfall will go up. And the natural disasters also, these are observations actually, which says that they are going up every year by year. All types of disasters, drought, flood, earthquakes, extreme weather, extreme temperature, volcanic activity, wildfire, glacial lake outburst, dry mass movement, wet mass movement, everything is going up every year. More and more disasters are happening, and the sea level, the heat content of the oceans are also increasing. We know that this is up to 700 meter. There are studies which shows that even up to 2000 meter is not spared even 2000 meter also is getting warmer and warmer. So the issue is that as the ocean water becomes warmer and warmer, the first casualty will be the coral reefs, then the ocean life, then the sea level increase, etc., etc. And the heat waves in the ocean are increasing. Even on the land it is increasing. There are reports just in March itself, Mumbai has hit about 40 degrees or 42 degrees temperature in March itself this year. So the heat waves are increasing, and the rate of change of sea level also has doubled, and sea level is increasing, which was earlier 1.4 millimeter per year. Now it is about 3.6 millimeter per year during 2006-2015. And we know that most of that sea level has increased because of the added water. Of course, the thermal expansion also has increased the sea level, but mostly because of the added water, because mainly we melted the Antarctic ice sheet, which added about 13.3 millimeter of sea level, as well as the Greenland ice sheet added another 15.2 millimeter of sea level. This is during 1972 to 2022 period, which lost several gigatons of ice sheets in that area. And because of that, the coastal areas will get flooded and people have to be displaced. For India, the assessment is that about 10 million population from the Indian coast will have to be displaced by 2050. It is not very far, just about another less than 25 years. We may have to make place for about 10 million people. That is 1 crore people will lose their habitat in the coastal regions. And there are reports the slowing ocean circulation. The Gulf Stream seems to be slowing down and getting warmer and becoming narrower towards the coast, which is keeping the European weather controlled. That is getting in trouble. And the southern oscillation also seems to be slowing down, affecting the conveyor belt circulation, which is the basics of entire ocean circulation. That is that also is getting in trouble. And Indian Ocean seems to be the most warming ocean. The heat content of the Indian Ocean is increasing at a current rate of 4.5 into 10 to the power 21 joules per decade. At that rate it is increasing. And this rapid warming is faster than average warming rate of other tropical basins. And heat accumulates from surface down to about 2000 meters. That's what the Indian Ocean is warming now. But we have very few observations at 2000 meters. We have observations, but not as much which is required. And because of that, there are several theories. It says that the Indian Ocean is gaining heat from the Pacific. That's what this particular study shows, that till 1973 Pacific was warmer, and then slowly Indian Ocean started becoming warmer and Pacific started losing. Then we have shown that that heat is mostly coming from, this is a paper which came from INCOIS, our student worked on this, and it is from this Tasmanian leakage, that is around the Australia. The water from warm water from Pacific is getting in, bringing heat and warming the southern part of the tropical Indian Ocean. And there are reports that it will alter the Hartley cell, which is basics of our monsoon, as well as the Walker circulation, it will slow down. So if these two cells get in trouble, our monsoon also can definitely can get in trouble. I think our climate center will come out with answers for these hanging questions which are posted today. So when we look at there are several industrial revolutions. If we say that industrial revolution started in 1800s, sometime in 18th century. Yes, the first industrial revolution was in late 18th century, coal-powered steam engines, mechanization of industry and transport, and a sharp rise in energy use and emissions. More and more coal started being used at that time. And the second industrial revolution, which came late 19th, early 20th century during our own lifetime, that's electricity, oil and gas became the primary sources of energy, mass production, chemicals and automobiles started increasing, and rapid urbanization and fossil fuel dependence has started with that. So we started adding to the fossil fuels as well. And third industrial revolution happened in late 20th century, for example, electronics, IT, automation, efficiency gains, but still fossil-based energy systems. That didn't change, it increased the demand. Now the fourth industrial revolution, that is what is going on today. Today also I was just having a chat with Dr. Ganeshil, and during our breakfast he was telling that now everybody wants to do the AI. Nobody is not getting people to run the models now. Everybody is going in AI. And AI is a data intensive. So that revolution is going on now. So digitalization, AI, advanced materials, enormous energy demand. And now we are talking about, we are not talking about kilowatts or megawatts. Now we are talking about gigawatts. Now a data center is coming up in Vaishak. I think how much, 5 gigawatts or 15 gigawatts. So we are talking about gigawatts. So where this energy is going to come from? So now our fourth industrial revolution is going to change the things or accelerate the things even further. Of course, the first industrial revolution mechanized the things, but the production increased. Then electrification started, electrified the things, then digitized. And there is one more revolution is going to come, maybe during many of your lifetime itself. That is the biological, biologize. That revolution is going to come out. Gene editing, gene therapy, and maybe brains can be altered with that. So all these things are going to happen. So bio-revolution is going to come soon, and many of you will witness that as well. So the Paris Agreement in 2015, we told that yeah, we will contain this, we cannot allow this to go just like this. So we will keep our emissions by 2025. And we'll try to achieve 1.5 degree centigrade warming by 2050. That was first decision. And we also added a rider at that time, if not possible, at least 2 degrees by 2100. So that was agreed. Every government signed on that. Of course, now our friends have gone back, but others are still there in that agreement, and we are trying to do that. But the question is whether we will be able to achieve that. The indications are that it is not going to happen. If you look at the IPCC report, it says that by 2034 we will be 1.5, not in 2050 at this present rate. But the reality is almost we are at 1.5 now itself. In 2025 itself we are there. And the WMO report says that the carbon dioxide levels increased by record amount to new highs in 2024. So we emitted much more in 24 itself, and WMO, I think, is throwing the hands. It says that no end in sight to rising greenhouse gas emissions, and this picture is going to become permanent everywhere. And if you switch on the TV now, you can see that the oil fields are burning and other infrastructure is burning in the Gulf region. Indian scenario is somewhat encouraging, or we are at least we are putting our efforts to contain this. We are not like our other friends who are talking at the and chairing those conventions and writing those resolutions. We are putting efforts actually, and we have now switched over to renewable energy. At least 40% of our installed capacity is from the renewable energy, which almost all our institutions. I am sure that IITM also has a big role in this, and we are trying to tap solar energy, wind energy, as well as other energies, renewable energies. So we are not very bad now, and actually the report says that we are on line to achieve the net zero what we are promised in 2070. So our promise is a solid promise, and we are on line. But we may have to do much more, because it matters to us, the climate change. Though it is a climate change is a global cause, but local realities are many. For India, it's highly exposed due to geography, population, and the developmental patterns. We cannot give up our developmental patterns. We have to develop, because we also have to improve our living conditions. And India is highly climate sensitive, because we depend on monsoon for agriculture. Monsoon is still a major economic contributor to our country, and for the food as well as water and many other purposes. And we have long coastline, Himalayan rivers. If ice don't exist there, then these rivers will melt, vanish. And food and water security is at risk. So erratic monsoons means we have problems for the food, droughts, floods, falling crop yields, groundwater stress. All these are very sensitive and very important for us. And heat and health impacts, because of the heat and other pollutants, our medical requirements also changes. More frequent heat waves, more people get sick because of the upper respiratory issues, and reduced labor productivity, higher mortality. And cities are under stress, urban flooding, heat islands, vulnerable informal settlements, etc. So we are very climate sensitive, and it is important. So we have to see that apart from government efforts to achieve net zero carbon emission, what we as people also can do, because our scale and diversity of the country is much more democratic policy making we have, so we cannot issue a order to control everything. Behavioral choices at household and community levels, local solutions are often most effective. So we have to take individual informed and active participation of citizens are a must. dialogue between science, policy and society should happen, and it should be encouraged, and valuing local knowledge alongside scientific evidence, because there is several local knowledge which is more useful, which we have not really tapped. So we have to make use of that and integrate that with the modern knowledge and modern the science. So individually, the individuals can do energy and water conservation, that has to be encouraged. Sustainable transport, waste reduction and segregation, civic participation and local leadership should emerge for that, and we should encourage that. And institution, media and scientists can communicate science clearly and honestly, engaging beyond academic spaces, listening to societal concerns. Media has critical bits to convey these messages back and forth. So we need a large public engagement, then only I think we can achieve that target. If we don't, then definitely we will, we might cross those climate tipping points. Today's Times of India, I was just going through, there is an article on how these tipping points are going to, and they say that Greenland ice sheet as well as Amazon forest and the deep water formation in the Atlantic. These three are going to get affected first, and once they happen, then the entire Earth will go in a hot house kind of a mode, and it can never be cooled after that. So these tipping points are staring at us, and we already had 5 major extinctions in the history of the Earth, and are we staring somewhere or starting at the 6th? I don't know. If we go like this and the Earth becomes a hot planet like the other planets, Mercury, the life will become impossible on this Earth, and I don't know whether we are going for a 6th. Anyway, it will take millions of years, so there is time for that. Already we had 4 major events in the past. So if I say that for the first time in human history, our greatest achievements and our worst fears are being born from the same source, that is scientific advancement. So this scientific advancement gave us most of the achievements, most of the comforts, and the worst fears are also coming from the same source, and that places an unprecedented responsibility on us, the scientists. It is with great conviction that I can say humanity has reached a moment unlike ever before, a point where our power to shape the future has outpaced our certainty about the consequences. We are living in an age where we can edit genes, teach mechanics to machines to think, and yet remain uncertain about the habitability of our own planet. This may therefore be the most defining period in human history, when human ingenuity has never been greater and human responsibility has never been heavier. So we are, I think, at that stage. Now we don't know how things will shape. So I will like to conclude with this sloka from Rigveda, which says that Om Samyat Sattvam Samadatvam Samvo Manadupati Jata Janatam Deva Bhagya Yada Purve Sanjana Upastate, which says that let us move together, march forward together in one voice harmoniously, and let our minds know together, just as the ancient gods shared their portion of sacrifice. Similarly, act together with unified understanding. So unless we all contribute, I don't think we can contain this climate change and make the earth a continuing living biosphere. Otherwise we will be destroying that biosphere. Thank you very much.